In this question, we have to find out the power that is required to maintain the constant velocity of the car despite of the resistive forces. Either it's a air drag or it's a frictional force by the ground. So the car engine is giving the constant thrust of 1500 newtons. So this is a force that the engine is applying to maintain its constant velocity, because there are the other forces. So that might be the force of the friction, the dynamic friction, or that might be the air drag, so FD. So in order to overcome these resistive forces, a 1500 newton of drag is required to move it with a constant velocity. And what is a constant velocity? Because it is moving with a constant speed, so you can find out simple: 100-meter is covered in 5 seconds, so that is 20 meter per second. Now what is the power? Before we directly apply the equation, let me show you what is the relationship between the power and force and velocity. So you know the power generally is the rate at which work is done. Now this work done is equals to right now the F force into the displacement. And in fact it is the, because the constant force is applied by the engine, so the displacement is increasing with respect to time. So when the power is constant, sorry, when the speed is constant, so you can say that this delta S over delta t, which is the rate of change of displacement, which is average velocity, is equals to instantaneous velocity. When the velocity is constant, then the instantaneous velocity at any instant of time can be written as average velocity, which is equals to delta S over delta t, is a gradient of displacement time graph. So the power, that's why it's a product of the force and the velocity, and we have to simply multiply it. 1500 multiplied by the 20, that will give us the 30,000 watts. So we can write this 30 kilowatts. So that's why the right answer is option D. 30 kilowatt is required to maintain constant velocity of the car.